The next quadrilateral that we're going to look at is our kite, and we have a picture of kite ABCD right here. And the definition of a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. We have this kite marked here. We have AB congruent to side AD, and then side BC congruent to side DC. So you can see that it is the consecutive sides that are congruent to each other. They are actually touching. So we have our, we could call it kind of our short side here, and then our long sides here. Alright, we have two theorems that we're going to look at, and then we'll do a couple of examples. Our first theorem is, if a quadrilateral is a kite, then its diagonals are perpendicular. So let's take a look at our drawing. We've got our tick marks in, marking our congruencies, and here's our diagonal. So very similar to the rhombus in the fact that the diagonals are perpendicular to each other. And our second theorem, if a quadrilateral is a kite, then one pair of opposite angles are congruent. So we look at our figure over here, and we have that angle B and angle D are congruent to each other. Angles A and C are not. Our first example, here we have kite ABCD. Over here we have angle DAB is 54 degrees. Let me get the 50 back in there. And angle CDF is 52 degrees. So that's this angle right here. So let's just kind of mark that. And I have put in our congruencies, my two consecutive sides here that are congruent to each other. And what we're going to do is we're going to find angle BCD. So angle BCD, I've marked, it's this whole angle here, and I've marked with an X so we know what we're looking for. Okay, so let's find this angle. When we're looking at the top part of our kite, we see that we have a triangle. And we have, actually, if we have two sides congruent, we know that we have an isosceles triangle. So if we have an isosceles triangle, then we know that those base angles are congruent to each other. So we're going to mark those congruent. So if angle CDB over here is 52 degrees, then I know that its other base angle is also 52 degrees. So given our two angles here, we can find angle BCD. So let's go back and look at what we did. We have our two sides that are congruent. We get that from our theorem, so we set those two sides congruent to each other, therefore giving us our isosceles triangle. And if we have an isosceles triangle, we know that those base angles are congruent to each other, which makes them equal. Therefore, we can find our third angle. So we take our 180 degrees for our triangle. We subtract the two angles that we know. 52 and 52 is 104 degrees. And we subtract those, and we have 76 degrees. So our angle BCD is 76 degrees. Okay, let's look at our next one. Okay, we have our same kite, and now we know that angle BCD is 76 degrees. We still know that angle A, down here, angle DAB is 54 degrees. Now what we're going to find is the measure of angle ABC. We're going to find this angle here. Alright, well, we're going to start off with basically what we know. We know that one pair of opposite angles are congruent. So that means we know that these two angles here are going to be congruent to each other. So angle ADC congruent to angle ABC. And we also know that a quadrilateral angle sum is 360 degrees. So we've got these two angles equal to each other. And now we know that all four of these together will total 360 degrees. So we're going to use our angle sum addition. Okay. We're going to take the two angles that we know, the 54 and 76, and we're going to substitute them into our equation down here. So there we go. And now we're going to find, we know that these are congruent to each other, so we're actually doing a little bit of substitution. Angle ABC and angle CDA are congruent to each other. So all we have to do is subtract the 76 and 54 from 360. That leaves us 230. And since we know those two are congruent together, all we need to do is divide by 2. And we get that each one of those is 115 degrees. So we know that this angle is 115. And we know that this angle is 115. So there's a look at our kites. I'm going to post a couple of questions for you to do on Edmodo when you work with your trapezoids, and we'll check those when they're due in class.